Have you ever really thought about how an email you send from your living room finds its way to a specific server halfway across the world in like a split second? It's kind of amazing. The whole internet really works like this massive, planet-sized postal service. And for any of that to work, every single device needs a unique address.
So, how does this digital post office actually pull it off? Well, that's what we're going to get into. We're going to break down what an IP address really is, figure out how your phone magically gets a new one every time you connect to Wi-Fi, and we'll even look at the clever tricks that keep the old system from falling apart. And then, we'll peek into the future at a really infinite address book that's built to last.
You know, the scale of this problem is just immense. You've got billions of phones, laptops, servers, you name it, all online at the same time. Trying to send a piece of data without a system would be like trying to deliver a letter in a giant city with no street names or house numbers. It would be total chaos. So obviously, we needed a system.
And the answer to all that chaos? The IP address. It is the absolute fundamental key that makes orderly communication possible. It makes sure every little packet of data knows exactly where it's going from your screen to its destination, across this huge network of networks. So, to put it simply, an IP, or Internet Protocol address, is basically your device's digital street address. It's a logical label that tells everybody else on the internet where to send stuff. It's the to address on every digital envelope. But it's really important not to get it mixed up with another key address. Yeah, this is a super important distinction. Your MAC address is permanent. It's a physical ID that's literally burned into your device's hardware, kind of like a serial number. Your IP address, though, that's temporary. It changes. It's given to you by whatever network you're on at the moment. Think of it this way. Your IP address is like your hotel room number. It's only valid while you're there. Your MAC address is like your driver's license. It's always you.
All right, let's take a closer look at the kind of address that's been the backbone of the internet for decades. This is the classic, the original, the real workhorse, IPv4. So, an IPv4 address is technically a 32-bit number. But to make it easier for us humans to read, we write it out as 4 numbers, we call them octets, separated by dots. Now here's the kicker. A 32-bit system means you can only have about 4.3 billion unique addresses. Back in the 80s, that probably seemed like an infinite number. Today? Yeah, that's a problem.
Now, to help with that shortage of addresses, some smart people came up with a great idea: private IP addresses. Your home Wi-Fi network? It uses these. They let all the devices inside your house talk to each other, but they are totally invisible to the public internet. The analogy here is perfect. The mail carrier only needs to know your main building address, right? The apartment numbers are just for sorting things out once the mail is inside.
Okay, so if these addresses are temporary, how in the world does your device get a new one every single time you connect to a new network? I mean, can you imagine having to type one in manually? It would be a total nightmare. Luckily, we have a really cool automated system for that.
It's basically a 4-step conversation called DHCP. When your laptop joins a Wi-Fi network, it just shouts out a discover message. A DHCP server on the network hears it and says, "Hey, I've got an IP address for you." That's the offer. Your laptop says, "Great, I'll take it." That's the request. And the server seals the deal with an acknowledgement. And it even tells you how long you can use it for. It all happens in a flash, automatically, every time you connect.
So we've seen how these private IP addresses help save space. But wait a minute. If those addresses are internal only, how do all of those devices actually get out to the public internet? Well, this requires another really clever trick, one that was absolutely critical for keeping the internet running.
It's called NAT, or Network Address Translation. Here's how it works. Your home router gets just one public IP address from your internet provider. NAT then lets all your devices, your phone, your laptop, your TV, share that one single address. When you go to a website, your router swaps your private IP for its public one, sends the request out, and when the data comes back, it remembers who asked for it and sends it to the right device. Your router is basically the busiest receptionist you've ever met.
And this is the truly brilliant part. Your entire house, maybe with 10, 20, 30 devices, can all be buzzing around on the internet using just this one single public IP address. It's an incredibly efficient workaround that squeezed so much more life out of the old IPv4 system.
But, you know, workarounds can only get you so far. With the explosion of smart devices, the Internet of Things, we needed a real long-term solution. We needed a new, way bigger address book. And that's where the future comes in, IPv6.
Just looking at them side by side, you can immediately see the difference.
We went from a 32-bit system in IPv4 to a mind-boggling 128-bit system in IPv6. And instead of those simple decimal numbers, it uses these longer, more complex hexadecimal codes. Yeah, it looks a little intimidating, but that complexity is what gives us a practically infinite supply of new addresses. And when I say infinite, I'm not really exaggerating. That number you're looking at, it's 340 undecillion. It's a number so big it's hard to even comprehend. To put it another way, we are not going to run out, ever. And this massive address space means we don't need clever tricks like NAT anymore. The future is a place where every single device can have its own unique public address. IPv6 also brings some powerful new tools to the table, like something called Slack. This basically lets your devices figure out their own IP address without even needing a server to hand one out. The device just listens for a message from the router to find out what network neighborhood it's in, and then it generates the rest of its own unique address. It's just a smarter, more decentralized way to get online.
Okay, so now that every device in the world can have an address, how do we keep everything organized and secure, especially in a big company network? Well, this is where we start creating what you can think of as digital neighborhoods.
By chopping up a big network into smaller pieces, or segments, you create these logical boundaries. This is so important for security. You can wall off the accounting department's network from the marketing department's, for instance. It also makes things run faster by keeping network chatter contained. One of the most common ways to do this is with something called a VLAN, or a virtual LAN.
And the actual technical process for building these segments is called subnetting. It's a really neat trick where a network administrator takes one big block of IP addresses and carves it up into smaller, more manageable subnetworks. They use something called a subnet mask to tell devices which part of their address identifies their neighborhood and which part identifies their specific house. It's really the ultimate tool for digital organization.
So when you put it all together, we've built this incredible system for addressing and organizing everything, from the early days of IPv4 and its clever patches, all the way to the truly infinite scale of IPv6. This system is the foundation for our entire digital world, and it leaves us with this really interesting question for the future. As the Internet of Things continues to explode, what happens when literally everything, every light bulb, every car, every coffee maker, has its very own unique spot on the global network? What new possibilities and what new challenges does that create?